my name is Talia. I'm an incoming second-year student at UCSD and I study chemistry. This YouTube channel is an extra resource for anyone who may be needing some help in their chemistry classes. Today I'm going to be explaining how to find the heat of a reaction using bond energy. So I'm going to be going over some basics about the topic and then we're going to get into an example problem. So if you would like to learn more about bond energy or work on your skills with bond energy, keep on watching. Without further ado, let's get started. So bond energy is the energy required to break a specific chemical bond. And also as another important piece of information, in a reaction, when you form a chemical bond, you release energy, and when you break a chemical bond, you require energy. So therefore, when we calculate the heat of reaction with bond energy, we are going to calculate the enthalpy by doing the total energy of the bonds broken minus the total energy of the bonds formed. And the reason we subtract the energy of the bonds formed is because this is a process that releases energy. And just like in an exothermic reaction, energy is released, or our delta H is written as a negative number. So therefore the same rules follow here. And this is different than our last heat of reaction equation, where we solved for heat of reaction by doing the heat of the products minus the heat of the reactants. Technically, the bonds broken are the bonds in the reactants, but we solve differently when we are using bond energy and kind of ignore the reactants and products and just look at which bonds are formed and which are broken. So you can also use algebraic manipulation and solve for the bond energy of a specific reactant or product if you know the enthalpy of the entire reaction. So let's get into an example problem. So for this reaction, we have 4 moles of NH3 plus 3 moles of oxygen gas yielding 2 moles of nitrogen gas and 6 moles of H2O in gaseous form. So we are going to determine the enthalpy and if the reaction is endothermic or exothermic. So our first step is that we want to determine all of the chemical bonds in our reaction, and specifically this is going to be all the chemical bonds between only 2 elements. So in this reaction, we're going to take element by element. If we start with ammonia, we have 3 NH bonds in ammonia. So if we have 4 moles of ammonia, or 4 molecules, that means we are going to have 12 total NH bonds, because we take the 3 from one molecule and multiply it by 4. Next, let's look at our other reactant of oxygen gas. In 1 molecule of oxygen gas, we have an oxygen-oxygen double bond. But if we have 3 molecules, we are going to multiply that by 3 and end up with 3 oxygen-oxygen double bonds. On our product side, N2 has a nitrogen-nitrogen triple bond, but we have 2 moles of N2 in our reaction, so we're going to multiply that by 2. And therefore, in this reaction, we have 2 nitrogen-nitrogen triple bonds. And then finally, we're going to look at water. In each water molecule, we have 2 HO single bonds. So therefore, in 6 water molecules, we are going to have 12. So that is how we break up the compounds into their bonds. And in our next step, we are going to assign bond energies to each bond and then use that to calculate the enthalpy. So I showed my work here. We are going to use the equation of bonds broken minus bonds formed. So our bonds broken are the 12 NH bonds and the 3 oxygen-oxygen bonds. And then our bonds formed is our 4 nitrogen-nitrogen triple bonds and our 12 oxygen-hydrogen bonds. So now we are going to assign bond energies to each of those bonds. And for this, you're going to want some sort of equation sheet or looking up the bond energies online. But I put in all the bond energies here. And you want to make sure it kind of cut off, but there's a bracket at the end of the bond energy for oxygen to hydrogen. You want to make sure that you're subtracting both or all of the bond energies of the products, which you can see that I did in my equation setup with parentheses in order of operations. So when we do that calculation, we get that the delta H, or the enthalpy, is negative 3,162 kilojoules per mole, and that is the unit of bond energy. So because our delta H is negative, that means that overall heat is released in our reaction. Okay, so even though heat is required to break bonds and heat is released to form bonds, our overall reaction is exothermic. No, that means that the energy released when the bonds form was greater than the energy required to break the bonds. And that therefore makes our overall reaction exothermic. So I know it can get kind of confusing with what requires energy, what releases energy, but the main idea to get in your mind is that the breaking of bonds requires energy and the forming of bonds releases energy. But when you subtract these two numbers, you can have an overall positive or negative enthalpy, which means an endothermic or exothermic reaction. And that, aside from the bond energies, can mean either heat is released or heat is absorbed in the chemical equation. So I hope you enjoyed this week's video on calculating the heat of reaction with bond energy. Next time I'm going to be calculating the heat of reactions using the heat of formation. So I hope you will join me back in that video if you would like some extra help with that topic. Let me know if you have any questions. Feel free to put them in the comments below. And I will see you next time. Good luck with learning chemistry.